Hi, good morning. I'm Upali Road and I'm going to talk about chapter 678 PowerPoint presentation. I have created 6 PowerPoint presentation for chapter 6 and 7. Today I'm going to do chapter 8. So the next test 3, going to start on November 4th and end in November 6th. We're going to talk about solution in chapter 8. Solutions are not only liquid solutions, they include all homogeneous mixtures. We're going to look into various types of mixtures, gas mixtures, liquid mixtures, and solid mixtures. When a solution is formed, the component in limited quantities are called solute. Solute could be divided into two categories. Some solutes are made up of ions or break down in the solution to make ions. They show electrical conductivity and they are called electrolytes. Non-solutes are called electrolytes. And those who don't break are not producing any ions in the solution. They are called non-electrolytes. We're going to look into that in detail. We're going to talk about solubility in general. Grams per liter is the general concentration of solute, grams in liters of solution. So solubility varies depending on the compound or the solute that goes into the solution. Solubility is affected by temperature and pressure. Solutions and liquid solutions are not affected by pressure, but by temperature. Some solubility of salts create cooler solutions or warmer solution, exothermic, endothermic. Depending on what temperature changes they show, they have an effect on solubility. On the other hand, gaseous mixtures, gas mixtures in liquid, gas dissolved in liquids, have an effect on temperature. As the temperature increases, the solubility of gas decreases, and as the pressure increases, solubility of gas increases. Concentration units are expressed in percent concentration, percent volume by volume or volume by weight or molarity. Concentration unit of molarity is very commonly used in calculation to get the moles of reactive material in stoichiometric calculations. One other thing we do with liquid solution is, starting with a concentrated solution, we create a dilute, less concentrated solution. So we take concentrated solution and add certain amount of water to it. So there's a common type of procedure we do in the lab called dilution. We're going to talk about it. Solutions show colligative properties. Colligative properties are properties that doesn't depend on the type of the solute, but number of particles that are present in the solution. The colligative properties are wave pressure, melting point, depression, freezing point, depression, or boiling point elevation, and also osmosis. Osmosis is a special case of separation of solvent solute particles through a semipermeable membrane. So only solute part of the liquid pass through the holes in the semipermeable membrane. On the other hand, dialysis is only letting pass the smaller solutes in the solution, and this is the way to clean your blood contaminated with metabolic waste. In dialysis is done on people with kidney problems. Again, instructional objective for chapter 8. I'm going to go over it a little bit again. We will describe the fundamental properties of solution and determine whether a mixture is a solution, colloid, or suspension. Liquid solutions are three types: regular solutions, colloid, and suspensions. Their particle size is increasing in the order from solution to colloid to suspension. Suspension have highest particle size of solute, so they are influenced by the gravity and get deposited at the bottom of the solution. On the other hand, solution and colloid have smaller particle sizes, and they stay in solution regardless of the gravity. So they are called solutions and colloids. So we're going to classify various solute into electrolyte and non-electrolytes. So we can predict, based on solubility rules, some compound is soluble in non-polar or solvent or polar solvent, and especially for water solutions, there are solubility rules that we're going to look into. Now, then we're going to predict temperature and pressure effects on the solubility. Temperature has effect on whether reaction is exothermic or endothermic. Pressure has only effect on gas, solubility of gases. We're going to talk about that in terms of Henry's laws. Calculating concentration units on solution is something that you need to practice. Concentration units could be expressed in volume by volume, volume by weight, percentages, or molarity. So we will define all these concentration terms. You need to know how to prepare dilute solution from concentrated solutions, which we call dilution problems. So we're going to look into the effect of dissolved particles on physical properties such as boiling point and melting point. So melting point is depressed and boiling point is elevated when you dissolve solutes in a solution. We need to understand process of osmosis, how it regulates biological membranes and dialysis. Osmosis is a phenomenon where concentrated two solutions of unequal concentration are separated by semi-permeable membrane. The solvent, in this case mostly water, passed from dilute solution to the concentrated solution and make the two solution concentration equal. Dialysis is a biological phenomenon in membranes where membranes have permeability only for certain particle sizes of solute. Large particle size particles, solute particles are retained, and small particles such as ions are preferably removed from the solution. This is application in patients with kidney failures. We're going to talk now in detail about solutions. Solutions are homogeneous mixtures that has uniform composition throughout the sample. Broadly, homogeneous mixture means solution. Solution could be many different types: gas mixtures, liquid solutions, or solid solutions, or alloys. So we're going to look into that in a coming slide. Solutions are generally called homogeneous mixtures, opposed to heterogeneous mixtures that do not have uniform composition and throughout the sample. Salad dressing is is a homogeneous mixture. Solution consists of two parts. One is the solute, the substance that present in lesser quantities, and the solvent is the substance present in larger amount. For example, if you dissolve a little bit of sodium chloride of sugar in water, solute is the sugar of the salt, and the solvent is the water. Aqueous solution is the solution where water is the major component of the solvent. There are three types of solutions. We're going to look into that. The first one is a gas mixture. Second one is the sodium chloride solution, liquid solution. Third one is a alloy, silver, mercury dissolved in silver, solid silver. All these solutions have uniform composition throughout the sample. The example of solution of gases is oxygen, carbon dioxide, and nitrogen, like exhaled breath. An aqueous solution of sodium chloride is a liquid solution, and solid solution is mercury dissolved in silver. So there are going to be solution in gases, liquids, and solids. The most commonly used in chemistry is aqueous solution or liquid solutions. Now we're going to look into classification of solute based on conductivity to electrolytes. The substance that conducts an electrical current in water is called electrolyte. That doesn't conduct electricity is non-electrolyte. For example, when you have ionic compound dissolved in water, they dissociate into ions, and when a current is applied to the solution, two electrodes are placed in the solution and current is applied, the solution shows conductivity. The ions pass through the solution to different electrodes and complete the circuit. On the other hand, neutral molecules such as hydrogen peroxide, which are not ions, or they don't break down into ions in solution, doesn't show electric conductivity. Therefore, they're called non-electrolytes. Sodium chloride dissociate into sodium hydrated sodium ions and hydrated AQ means hydrated chloride ions. Hydrogen peroxide doesn't dissociate. They don't break up into ions in water. Solubility depends on temperature and pressure. Solubility is the amount of solute dissolved in a given amount of solvent. Normally grams of solute per liter of solution for liquid solutions. Solution which contains maximum number of grams of solution that can dissolve. That means you can, at a particular temperature, you cannot dissolve any more solute into the solution. So some solute remain in the bottom of the solution. An unsaturated solution is the one that can have more solute added and contain less than maximum number of grams of solute that can dissolve. Solubility. Solubility is summed up in the statement like dissolves like. So mixing up of solute and solvent depend on their type of intermolecular forces they hold in the solute and solvent separately. So like dissolves means the compound that have similar intermolecular forces are like and dissolve in each other. Most ionic and polar compounds are soluble in water. So it's that produce the compound solute that has polarity in the molecule or ions are dissolved in polar compound, polar solvents. For example, sodium is hydrated in water to produce hydrated sodium ions and chloride ions. So therefore they separate, they are in a way having electrostatic attractions. They behave alike. So polar compounds, ions dissolved in polar compounds, such as water. Small neutral molecules with oxygen and nitrogen atoms that can hydrogen bond to water are water soluble. For example, water and ammonia and HF are compounds with oxygen and nitrogen atoms. They form hydrogen bond with water molecules. Therefore, they are alike in certain ways, forming hydrogen bonds between each other. So they are soluble. So ethanol in this picture dissolved in water. OH groups in water molecule can hydrogen bond to water dipoles, making hydrogen bond between hydrogen of the water molecule and oxygen dipole of the ethanol molecule. Ethanol can hydrogen bond to water, as I explained in here. Solubility. Nonpolar compounds are soluble in nonpolar solvents, like dissolves like. Nonpolar liquid that exhibit only London dispersion forces. So we look into ionic compound and hydrogen bonding compounds, and now we're going to look into nonpolar compounds, molecules that dissolve in nonpolar molecules. That molecular attraction between nonpolar is molecules are London dispersion. instantaneous dipoles form between the particles. Octane is a nonpolar molecule which dissolves in carbon tetrachloride, which is nonpolar. Both are nonpolar, exhibit only London dispersion forces. So octane is shown in here, and the carbon tetrachloride molecules are shown there in the second picture. So they interact through London dispersion forces. So it explains like dissolve, like what is like in the case of nonpolar compounds such as octane and carbon tetrachloride. We're going to look into the effect of temperature and pressure. For most ionic and molecular solids, solubility generally increases as temperature increases. There are few exceptions where the solubility decrease because of the endothermic reaction, exothermic reaction, because of the exothermic reaction. By dissolving solid in a solvent at high temperature and allowing to cool slowly, a solution, a supersaturated solution can be made. There's a metastable state where solution holds more solute than it normally would. So the supersaturated solution are used in heat packs to keep hand warm during cold day in outside activity, doing outside work. Supersaturated contain more than the predicted maximum amount of solute at a given temperature. In contrast, solubility of a gas decreases with increase in temperature. If you warm up your carbon dioxide or soft drink, carbonated water or Coke drink, it will release the carbon dioxide and become flat. The solubility of the gas in liquids is proportional to partial pressure of the gas above the liquid is called Henry's law. So higher the partial pressure, higher the solubility of the gas in the solution. The higher the pressure, the higher the solubility of a gas in a solvent. Carbon dioxide is a common example in carbonated water or soft drinks, where carbon dioxide is dissolved at high pressures and kept at low temperature to keep carbon dioxide gas after opening the bottle. Closed can of soda have higher carbon dioxide pressure, therefore higher carbon dioxide solubility. Low pressure, once you open up that bottle, that open can of soda, lower carbon dioxide pressure. So they release carbon dioxide and deplete carbon dioxide gradually from the solution. We're going to look into concentration units. Concentration means relative amount of solute to total amount of solution of a solution. Parts divided by total multiplied by 100. The parts could be taken up in weight. W is weight. V is for volume. Volume by weight. There are so many ways solution concentration percentages expressed. Volume by volume, weight by volume, volume by weight, depending on the physical state of the solute and the solvent. Weight by volume percent concentration given as W divided by V percentage is the grams of solute dissolved in 100 millimeters of solution. So that's a common solubility. Solubility is shown commonly in this unit. This is called weight volume percent concentration. You take the solute in grams and measure the total volume and divide it by to find out how many 100 milliliters are in the solution. Then divided by 100, you get the S given below. Mass of the solute is D, volume of the solution is in milliliters multiplied by 100. Volume by volume concentration is called volume percent. Volume of the solute in milliliters, volume of the solution multiplied by 100. In this case, both solute and solvent are liquids. That's a convenient way to measure volume by volume concentration. When concentration are very lower than, much lower than percentages, we use parts per million. Parts per million is rather than multiplying by 100 to get percentages, we multiply by 10 to the 6. That gives a concentration, a reasonable number to handle it. So otherwise, there are a lot of zeros expressed in 100% units of percentage. So they couldn't be volume of solution, volume, mass of solution, mass by mass, or volume by volume, ppm. Molarity is a most common solution concentration unit. The molarity is the number of moles of solute per liter of solution, abbreviated big M. Moles of solute divided by liter of solution. So there are problems calculating concentrations, either percentage or molarity. You need to find out, in this case, in percentage, mass of the solution or solute, or the mass of the solution. And in the case of molarity, you have to find out how many moles are in the solution and divide it by total volume of the solution to calculate molarity. We use conversion factor, moles as a conversion factor to get the moles of solute present in volume of certain solution, volume V of certain solution. M times V is the number of moles. So that has been used in stoichiometric calculations directly to get the moles of reactants or products. Volume of solution is, on the other hand, moles of the solute divided by molarity is the volume of the solution. If you are mixing up volumes, you can convert moles to volume of the solution. Dilution is a problem that we encounter in daily laboratory lab work. We start with the concentrated solution, and dilution is adding solvent to decrease the concentration of the solute. the solution volume changes, but the amount of solute is constant. For example, there's a standard initial solution, concentrated. When you add water, you have still the same number of solute particles, but the volume is higher. So therefore, V times molarity is constant in both solutions. Volume times molarity times the volume. So molarity times volume, initial molarity, initial volume is equal to molarity, second solution and dilute solution, molarity, and volume of the second solution, dilute solution. So initial values, final values. So we can either know in the molarity of the concentrated solution, initial solution, and knowing how many volume of second molarity the diluted solution are required, you can calculate how much water needed to be added to the solution to get that dilute solution. Colligative properties. Colligative properties are properties of a solution that depends on concentration of the solute, but not on its identity. Which also means number of particles of that are present in the solution. Thus, the number of dissolved solute particles affect the properties of the solution, but identity of the solute doesn't. Colligative properties include elevation of the boiling point, lowering of the melting point, and pressure, osmotic pressure. These are colligative properties. So we're going to look into colligative property, boiling point elevation. Boiling point, when you dissolve substance in water, the boiling point is higher than pure water. A volatile solute readily escapes into the vapor phase, with a non-volatile solute doesn't. So that means when you have a non-volatile solute dissolved in a solvent, it hinders escaping of solvent molecules into the gas phase, then lowers the vapor pressure. Therefore, you had a boiling point is defined as pressure at which vapor pressure of the solution is equal to the atmospheric outside pressure. Boiling point elevation. A liquid solution that contains non-volatile solution have higher boiling point than the solvent alone. The amount that boiling point increases depend only on the number of dissolved particles. That's a colligative property. 1 mole of any non-volatile solute raises the boiling point of 1 kilogram of water in the same amount, 0.51. Any 1 kilogram, same amount. Now we're looking at freezing point has the opposite effect on freezing point. Freezing point depression. A liquid solution that contains a non-volatile solids have lower freezing point, unlike higher boiling point. Freezing point is depressed. The amount of freezing point depression depends on the number of particles dissolved in the solution. 1 mole of any non-volatile solute lowers the freezing point by 1 gram by the same amount. So this is similar to boiling point elevation, but different effect. Osmosis, the cell membranes in cells are called semi-permeable membranes. They isolate the cell from the surrounding. Semi-permeable membrane allow water and small molecules to pass through, but ions and large molecules cannot. So only the solvent pass through the membrane from lower concentration to high concentrated solution. Osmosis is the passage of water and small molecules across semi-permeable membrane from solution of lower solute concentration to solution of higher solute concentration. In this picture, the passage of water molecules through a hole in the semi-permeable membrane is shown. The solute molecules are bigger, so they cannot pass through the small holes in the membrane. Osmotic pressure is the pressure that prevents the flow of additional solvent into solution on one side of a semi-permeable membrane. So if you put a pressure on the solvent only side, you can keep water molecules pass into the concentrated solution. When you add salt water to one side of semi-permeable membrane, the fresh water pass through the semi-permeable membrane and increase the height of the salt water column. So that extra pressure that applies pushes water down the semi-permeable membrane. Dilution of water flow is shown in this diagram. There are three types of situations that occur due to osmosis when a cell is placed in a solution. Cell is placed in a solution with the same osmotic pressure as the cell. It stays same. Isotonic solution is cell doesn't change size or shape. This is a red blood cell. Hypertonic solution is when you low osmotic pressure as the body is the cell. So that become bigger than the normal cell and absorb water diffuse into cell. Hypertonic solution is when solution has higher osmotic pressure as the body, that's the concentration is higher than the inside. Then water seeps out of the cell and the cell become smaller. That's a hypertonic solution. Cell get smaller. In hypotonic solution, cells can burst open because of the water coming into the cell. Hemodialysis is a cleaning of blood through dialysis. So a person with impaired kidney function are hooked up to a machine called dialysis machine. So they pass the solution through the blood through a maze of the selectively passes through a membrane that selectively remove salt ion and small particles of solute and cleans the blood. So that's what the kidney does in a non-healthy person. In human body, blood is filtered through a kidney by a process of dialysis. In dialysis, water's small molecules and ions can pass through semi-permeable membrane. Only large biological molecules like protein and starch molecules cannot. So basically, dialysis machine removes water and other small particles, ions from the blood and cleans it up. This allows waste product like urea to be removed from bloodstream and eliminated in the urine. So I'm done with chapter 8 and hope you go through this and take your test 3 on November 4th. Thank you very much. Take care. Bye-bye.